Hello again, Williston Scholars. Today we will be looking at another problem. This from section 7.7, improper integrals, and this is problem number 11. So right now, we have this integral here, and it's a pretty standard looking integral. It's x over e to the x dx. But what makes this curious and what makes this an improper integral is that it is from 0 to infinity. Now, which infinity is not a real number. So infinity is not a real number. It's an abstract concept. You can't go to infinity, despite what Buzz Lightyear will tell you. So he says go to infinity and beyond. That's just not possible. So what we need to find this, we need to figure out a limit. So what we're going to do is we're going to first convert this into a limit, and then we're going to solve for the limit. So here's what we're going to do. So we're going to do the limit as b approaches infinity of b to 0 of x over ex dx squared. So that's our first step. So now we have the variable b standing in for infinity, and as b approaches infinity, as b gets infinitively, oh god, I can't speak. As b gets infinitely large, there we go. We're going to see what happens to x over ex, the integral of x dx. So let's take a look at that. But now we need to solve the integral. So how do we do this? So we're first going to do some integration by parts. So first we're going to convert this into something a bit more solvable, which is going to be x to the e to the negative x dx. And now it's all on one line, which is nice. And we still have over here limit of b to the infinity. That's an infinity sign, folks. I'm amazing. So yeah, so that's that. So now we're going to use some integration by parts to solve this. So let's do that right. So now we've sorted those into our different parts. So we have the u, we have the derivative of u, we have v, and we have the derivative of v. And now using this over here, we can solve for our integral. So let's do that right now. So we're gonna now we just can plug and chug these in. So all this equals the limit as b approaches infinity. We have to keep that in mind. We're going to use that. That doesn't happen until the very end, and we're going to start plugging these in. So it's going to be negative x to the e negative x minus the integral of negative e to the negative x dx. Okay? Close parentheses. So yeah. And another curious, but we have to keep in mind that this is for an undefined integral. We have a defined integral. So what we have to do is we have to add this in, which is so this is negative x. So because this is solving for an integral, oh my god. Because this is solving for an integral, we have to put this in, b to the 0, because that's what this whole equation is from. It's from b to 0, because this is from b to 0. So the solution also has to be from b to 0. So now we can do some more things. So now we can go down a little. My tablet will allow me. And we're going to start. So now we can do some more things. So we're going to do more. Limit as b approaches infinity of negative x. I'm going to put this over. I'll put ex minus, and now we can solve the integral, and I'm going to take out this negative and put it right here, so plus the integral of e to the negative x dx, close parentheses, and all that is from b to 0. And now we need to solve for this for the integral of e to the negative x, which is pretty simple actually. That's a nice integral that we can solve, which is good. So b is b approaching infinity. Again, we need to write that out. I hate having to write that out over and over. We have e to the x. We have negative x. I'm sorry, over e to the x plus, and then we solve this integral, which it comes out to be negative e to the negative x. Another close parentheses, b to 0. So there we go. So now we have all our integrals out. And now what we need to do is we need to, and so I'm going to simplify this just a little bit more and do limit as b approaches infinity of negative x ex minus 1 over ex. Okay, so that's where we're at now, and that's from b to 0. So now we need to plug in the b and 0, that part, and do that part. So now we have equals, so that all equals limit of b approaches infinity. God damn it! How many times am I going to have to say that? And now we plug in b for x, b and 0 for x. So we're going to have negative b of e to the b minus 1 over e to the b. Actually, and we can simplify this out to be just that. So negative b minus 1 all over eb. So that's going to be that part. And then that is going to be minus negative 0 minus 1 over E0. Okay? So that's it. So now, because now we plugged in 0, we plugged in B, we plugged in 0, and we subtracted from each. So now we can simplify this out, and we get limit as B approaches infinity of negative B minus 1 over EB minus, and this turns out to be negative 1. So all together now, that equals limit as B approaches infinity of negative B minus 1 over EB plus 1. So that's all fine and dandy now, but we still have to figure out what's going to happen with this B. So now we have to think about what happens when B goes to infinity. And since B isn't in this one part, we have to think about what does it do, does this do as B gets infinitely big? Well, here's what happens. So we know the top goes to infinity, so it seems like it's just gonna blow up, but it doesn't, because EB is going to grow even faster than, because the limit of B as B approaches infinity of B is less than the limit as B approaches infinity of E to B. Thus, the denominator is going to become bigger, meaning that this is going to become infinitely smaller, and thus, it's going to go to 0. So our final is going to be 0 plus 1, or just 1. Meaning that if we go back to our original equation, that equation now, our original equation, equals 1. There you go. You have now solved an improper integral. Yay! Hope you enjoyed that. Alright. Bye.